Right. Just to get started, can you guys hear me at the back?
Yes.
We're good? Perfect. Awesome. Alright, so before I get started, I want to just ask a few questions to know more or less what the audience is like in terms of the topic. So please raise your hand and keep your hand up throughout these next 4 questions. So who here has very good. So who here has heard of machine learning? Okay, keep your hands up if you have mildly intuitive understanding of how machine learning works. Okay, around 100%, that's great. Now keep your hands up if you have developed maybe a prototype or in your own machine learning model. Okay, still around 60%. And keep your hand up if you have deployed and maintained a machine learning model in production. Okay, so probably around like 20% or less. Awesome. All right, well, so it's the perfect time for the talk to make sure that we introduce best practices before it's too late. Awesome. So today I'm going to be covering a practical framework and an overview for building machine learning systems responsibly. This is of course something that will continuously be iterated, but I'm going to be covering basically some of these areas. A bit about myself. I am currently the chairman of this think tank called the Institute for Machine Learning Engineers. We basically build frameworks, industry standards as well for best practices around the development of these machine learning systems. I'm also the chief engineer and scientist at Exponential, and I have experience leading data science teams, machine learning teams, as well as deployments in production across many sectors. And I'm also involved in several other initiatives as member or advisor. Today I'm going to be doing a deep dive on basically motivations of why it's important, a brief overview about the Institute and how we're approaching these potential issues, and then diving into this approach towards developing these machine learning systems. All right, yeah, let's do this. So let's get started with the motivations and why we should care about this topic. So in terms of like the traditional data science workflows, it can normally be abstracted into 2 main workflows. The first one is on your development of the model. This basically consists of you getting some data, doing some cleaning of that data, trying to understand how to represent that data in terms of features, choose a few models, and then define your accuracy metrics so that you can assess how these specific models with this feature performs in this data, right? With the objective of, once you're happy, you want to persist this machine learning model that is already trained, and you want to go to the next step, which is basically serving your model in production. You want to put this model so that it can do inference to get results, to either automate or make a specific process more efficient. So basically getting new unseen data, pushing it through the data transformations, getting an inference, and then doing something with the results. And when you have a small team or a simple data science project, we can cope with issues that arise without too much complexity in our infrastructure. We have a small number of models to maintain. Our data scientists can have the knowledge in their brains, and that's okay. And they each have their methods, their tools, and because it's not that many, it's okay. It all works relatively well. However, as our data science requirements grow, we face new issues. Some of these issues can be around the complexity of the data flow. Right? You may have started with some cron jobs, running your scripts, but then you realize that there are very complex dependencies, and you end up in cron job hell. Your data is being modified in areas that you're not aware, and you don't know where the previous unmodified data set is. So managing the complexity of the workflows gets out of hand. Then also each data scientist has their own set of favorite tools. Some love TensorFlow, R, Spark, etc., etc. Some love all of them. If your option is and your decision is like making sure that at a large data science function everyone just sticks to one, it's going to be hard because ultimately each of the tools are good for specific each of the use cases. And then also serving models, it becomes increasingly harder, right? You have different versions of models at different areas. Maybe something goes wrong and you need to pull back a specific model. Maybe you need to debug something in production, and it becomes much harder. You have some models that require different resources, computing resources. Some may require GPUs, some may require a large number of RAM memory to be able to do the computations, and that becomes more complex. And also when stuff goes wrong, it's also hard to trace back, right? Like data scientists, says it's a bug in the pipelines. Data engineer says it's something wrong in the models. It becomes a cat and a mouse game where everybody's just pointing fingers, going like, "Not my fault. You can't prove it. I don't know what happened." So the challenge of reproducibility is something that has been there for a long time. And luckily for us, unlucky for the rest, is that everybody has these challenges. We're not unique, and that's interesting because that actually has led into the development of new roles. And right now, the role that we're starting to see is this role of the machine learning engineer, which is an interesting one because when the Hadoop craze started and when everybody was talking about this big data craze, there was a new role emerging, the Hadoop engineer. Basically, the engineers that are tasked on maintaining these systems. Now you're talking in the same terms about maintaining your infrastructure for data science. So it's a very interesting wild west that is currently being explored. So as your technical functions grow, what basically is being proposed is that so should your infrastructure. And the way that we break it down in terms of your infrastructure, data science infrastructure, is having your inner layer of machine learning operations. And this basically consists of two main cores. The first one is reproducibility, which is model and data versioning. The second one is on orchestration. This is basically on monitoring, continuous delivery, and orchestration of the computation itself. And that's hard because you're basically talking about building a pretty much an operating system, but a distributed operating system that is looking to allocate resources across nodes. And when you're talking about software being your TensorFlow cluster or your Hadoop-based systems, your Yarn nodes, etc., etc. And basically not super relevant to this talk, but we've put together a list of open source tools that focus purely on machine learning operations. Things that allow you to do reproducibility, orchestration. So please do contribute. It's an open source list. It talks about all the ways, even to differential privacy. So if you go bit.ly, awesome MLOps, do feel free to have a look and also contribute if you know of any other systems. But yeah, so now that we know the premise of the motivations, now let's see how we can try to approach this on a day-to-day basis when developing these systems. So what we're currently doing, we set up a think tank that focuses primarily in the practical perspective of these challenges. So this is less on the more philosophical or like business specific, but this is more on the technical side. The institute's website is ethical.institute, so you can check it out. And basically there is where we state our ethos and the way that we approach it. The way that we execute is on a 4-phase strategy, which I'm going to cover in a bit. And we basically abide by these 8 machine learning principles that we're going to be covering. And the way that we try to operate and tackle these issues is using this thing that we call the moral consciousness matrix. And this is a very funny thing. The emojis allow you to understand a bit of what we mean. But basically, moral states on wants to do good, an individual that wants to do good, and conscious refers to knows how to. So you can have people that are moral and conscious, and that's great. So that's people that want to do good and know how to do it, right? They will be able to go and develop these systems, and they know what the best practice is. That doesn't mean that they're going to ultimately do it, but at least they have frameworks to approach it. You also have people that are moral, unconscious. They may want to do good, but they just don't know how to. And for that, those are people that, we have to try to provide these frameworks and best practice approaches on how to do that, right? So similar to in how software development, if you see somebody that is not writing unit tests, other people may frown upon. It's not something that is done all the time, because business will always push back, until it's too late and they go like, oh, why is there so many bugs? Why does it cost so much to do one change? But it's ultimately, this principles. Then you have the little gremlins at the bottom left, which is basically the conscious and immoral, right? People like Cambridge Analytica that know they're doing wrong and still do, right? Because it makes money or some reason. And then you have the unconscious, immoral, which I normally say, don't worry about that. I mean, I haven't really found a case study where those people are in a position to really cause massive, and maybe there are, but those are the three that we're focusing on. And basically the rollout plan is the approach on 4 phases. The first phase is to tackle this moral and potentially unconscious. It's not the best word to use, unconscious, but basically people that want to do good but may not know where to start. And this is basically trying to provide the frameworks for technologists to be able to go off and do it, and also advocate towards these best practices. The second phase is trying to tackle by process. This is by trying to instill these fundamental best practices through the processes that are done on a day-to-day basis. This could be done through the Scrum sprints. This could be done on a perspective of procurement managers when trying to procure a new technology, to be able to set a set of standards to say like, hey, it needs to at least have and prove that you have done these things. The third phase is by certification. So we're contributing to a few standards, more specifically the IEEE standard for algorithmic bias considerations. This is something that will be coming up in the next 2 to 3 years, and that will allow on an industry level to ensure these best practices are taken into consideration. And then the last 4th phase is trying to gather case studies to be able to influence policymakers so that it can protect on economy level. So these are the 4 phases, and our core focus has been on the first phase through these 3 main work streams. The first one is the 8 principles, which I'm going to cover. The second one is open source contributions, like this machine learning operations list, and a few tools that we're developing to identify bias in machine learning models. And the third one, which is basically the ethical machine learning network, which is a fancy name for our newsletter. We just have a play on words because our ethos is that, although you may argue in AGI or some of that stuff, we argue that the only ethical machine learning network that can be embedded with ethics in a practical application is that one made out of humans. Ethically aligned humans that want to continuously pursue best practices. And yeah, you may argue that in this kind of conversations you have to embed ethics, but we focus more on like the today and next month and next few years. So yeah, let's jump into the actual 8 principles. So the 8 principles are covered in detail in ethical.institute/principles. Basically, this consists of 8 best practices to be conscious when approaching the development of these machine learning systems. In summary, this includes human augmentation, bias evaluation, explainability, reproducibility, displacement, strategy, accuracy, trust, and data risk awareness. So let's dive in. So for the first one, human augmentation. So this basically is about committing to assess where impact of incorrect predictions I'm aware that the GIFs are a bit distracting, so I even added animation to remove it. But yeah, so assess the impact of incorrect predictions and design human-in-the-loop review processes where reasonable. So when talking about and seeing some of the use cases that appear when implementing machine learning models, some are actually quite obvious where you must have a human to do the final decision. Things like sentencing prediction for deciding whether somebody should leave prison because of their behavior and several other factors. There was a few systems that were developed to do that end-to-end, fully automated, and it raised a lot of ethical implications, which is very reasonably with what. And other areas like fraud detection is places that would actually benefit and would work better if you have this human-in-the-loop review process. Ultimately, there are a lot of areas where machine learning is being used. Most of them are for automation of processes, and when approaching this set of processes, and when there are maybe hundreds of people doing that specific job, instead of approaching it to say, hey, how can we have this end-to-end automation of this 100 people, there may be the opportunity of saying, how can we make sure that there's still 5 of those people at the end, making sure that the predictions were valid, or using these predictions as suggestions for them to be able to gather more insight into those decision-making processes. An example where this has been done in the past is potentially around back office automation of some sort of text, and this is a specific area where it may benefit from actually having a human to check for the last process. The second one is on bias evaluation. So this is a very, very interesting one because any non-trivial decision will have an inherent bias, and some data sets will have an inherent societal bias. This could be on specific data points or specific features having a bigger importance in your inference results, and having a bigger importance in predicting a correct result, right? This could be features like ethnicity, this could be features like gender, and various other areas. So a lot of the times people go into the discussions of what are the best practices to tackle these issues. And a lot of the times people try to tackle this, trying to look at these machine learning models, and they say, well, we're using deep learning models that are too complex. And when analyzing the individual nodes, it's impossible to assess what the weights are doing. So at the same time, there's this perspective like, well, you don't know what is coming in, and that will cover in the explainability piece. But there is many ways where you can actually assess the impact of each of the features based on the results that they actually predict. With the data itself, you can also analyze the data and see if the actual data you obtain is representative, right? Like you can see that it may have many more examples of a specific category than from others, and that in itself may incur a bias that can be avoided from the very beginning, right? So the second one is, from the perspective of, bias evaluation is hard, right? Is what are you trying to make sure that you have? Is it equality or is it equity, right? Ultimately, this is something that is not just up to the developer to decide. And when you deploy a system that may have an inherent societal bias, which maybe not possible to remove, there is a danger that that system may reinforce that bias in society. And there may have to be some things that should be put in place to potentially skew that towards another perspective. However, that decision should not be on the hands of just one developer or one data scientist that is developing this model. So what we propose is basically to take a step back and focusing on what is important for the development of these systems, and that is on identifying and documenting the bias that is currently in the models. What features have a higher importance? What features may have more effect? And it is up to that specific use case and to the specific larger operational transformation that is being driven to decide how to deal with that bias. But the responsibility should be on making sure to identify those inherent bias on either the data or the features themselves. The third one is on explainability, and that basically is quite a good segue from the bias detection. Explainability often is something that comes into play for two reasons. The first one is sometimes you may find with the deep learning craze that deep learning models may perform significantly better, right? But it shouldn't just stop there, and you shouldn't just be like, well, we developed this machine learning model or this deep learning model that just performs really well, and it's impossible to explain it. Because a lot of very interesting use cases have shown that it's possible to introduce explainability even with these deep learning models. And this is by introducing, by different approaches. One of them is by potentially introducing domain knowledge into your features. So ultimately, what is a deep neural network doing? It's trying to find patterns in your data that a human normally wouldn't find. Once you train a deep neural network, it may find some things that actually you could give them a priori. You could say, some domain expert, some lawyer, or some financial analyst that has tons of experience on analyzing this specific data set normally looks at these areas, normally looks at these things. So how can you actually introduce that domain knowledge into the systems? Another example is when people approach deep reinforcement learning or things like that, where you're in some cases teaching these models and making these models learn the fundamentals of physics from scratch, as opposed to you being able to instill those as features or as rules within the system itself. And more specifically in this domain knowledge as features, it has shown that by adding this specific more information, the model can even perform better. Now, there's a second area where maybe you are not able to add as much concise domain knowledge as features per se, but an approach that people have been having is to abstract their neural network architectures into some sort of a set of modules, where, for example, you have a deep neural network that instead of trying to do the entire thing, one network is focused on identifying cars or objects. Another neural network is focused on identifying humans. Another neural network takes those specific inputs and then tries to do a prediction on what to do then. That's something that a lot of self-driving car companies are taking this approach in. So even though you still have very complex models doing that inference and individually may not be explainable, you're still able to know like what is the architecture of your system, and if something goes wrong, at least you can know what part of that system to assess. And another point to make is there are also tools that allow you to assess bias. I'm not sure if you're familiar with TensorBoard, but there's a tool that allows you to analyze your TensorFlow models. This is basically the what if screen that allows you to understand and analyze, as I was saying, the feature importance together with your inference results. So basically this is a classification of individuals based on whether the classifier thinks they earn above 50K or under 50K. And what you're able to do is you can actually see the importance of each of these features based on what the incorrect labels are or correct labels are. For example, here we can have gender-based binning as well as splitting them in terms of like correct, incorrect. So you can actually dive into your data set, and even though it may be a very complex model that you're using, you can still try to understand what each of the features is doing. In terms of reproducibility, this is on reproducible systems. This is on making sure that you can actually reproduce your results. This involves also compliance, on making sure that you're able to also have a way of understanding what went into your model, in production, for example, having an audit trail of the data that passed through the system. And the way that we cover it in the machine learning operations framework, a list that we mentioned previously, is in this concept of seeing each of your areas that you're using data for, and basically abstract it into basically 3 key things, right? On each of these computational steps, you are going to have some data coming in, you're going to have some code that is going to do something there, and you're going to have some configuration around it for the code to work. And if you have these 3 key things, no matter where you are, you're going to be able to reproduce that step atomically over and over again, right? Once you have one computational step, that is reproducible, you can then actually have your entire model having this different feature generators, the model that you chose, as well as the data cleaning as atomic computations that can be reproduced, right? And there are actually many libraries that approach this challenge of reproducibility in very interesting ways, which you can find on the list, and please have a deep dive and contribute, as they're doing really cool stuff in how to improve reproducibility in production and development. So whatever your data scientists are able to create in development, you're able to take it and deploy in production, and it will work the same way. Likewise, if something goes wrong, you're also able to reproduce it. Number 5 is displacement strategy. So this is basically on being aware that medium to large scale rollout of an automation system will have an impact on people. And this not only focuses in that story or that storyline that covers about maybe unskilled workers or farmers being displaced, but this also covers beyond the level of skill of the worker. This could also be going into a large corporate and replacing a system. That is going to have a business impact, because the people that are on that specific job need to move into something else. And this is the very old conversation of business change, and this has been present for years and years. Ultimately, again, this, similar to bias, this is not responsible to the engineers themselves, to the data scientists themselves, but it is from the data scientist perspective to make sure that they are aware of the potential impacts and the benefits as well, the cost reductions that these systems do, beyond it just being a cool algorithm that gets very high accuracy. And there's this very interesting concept called Chipman's paradox, which basically states and talks about how during the Industrial Revolution, when machines were being more efficient, it was thought that because each machine required less fuel to be able to deliver the same results, people thought that the total fuel consumption of the industry would decrease. But what ended up happening is, because the actual price also decreased, the demand increased. So ultimately the total fuel required to power the whole industry ended up increasing. This is something that we're also seeing in some cases of deployment of machine learning systems, that it may make a specific service, like legal services, more affordable, and even though you may require less people to do that task, the fact that now the legal services are more reachable because of these machine learning systems, then you have a larger inflow of demand for these specific services, right? So it is the responsibility of, when building a system, is how can I make sure when it becomes of a larger scale that I'm gonna roll it out, and that I can retrain and reskill the people that are gonna be using this platform or this system or this app or whatever it is. For the 6th one is practical accuracy. So this is basically taking a pragmatic approach towards defining your accuracy and cost metrics. So this is not like the conversations that go like, oh, how can you give empathy in your cost function? None of that. This is basically, don't just take accuracy as your metric. Understand what your precision implications is. What is the implications of a false positive? What is the implications of a false negative? Which one should you focus more on? How do you define your accuracy for you to responsibly put your model in production and not feel bad about it? How are you going to monitor your models in production and when should you pull your model out when some of the metrics reach lower than a specific point, based on what you stated. And this is very, very domain specific. Also, when it comes to your cost functions, what may be seen as just a simple, approach for a computer to compare certain results may be initially like a sensible way to compare the results for your cost metrics, but maybe a human actually thinks of something being correct as different once you reach this domain experts and you ask them, hey, what actually would you consider a correct result, and what would you consider an incorrect result, etc., etc. So this is very, very important to take into consideration, because many people just use the measurement of accuracy as this primary objective, as like their business goals, and once it reaches 90, just push it to production without really understanding the implications for that specific use case that you're carrying forward. Number 7 is trust beyond the user. And a lot of focus that I have is not just on B2C, because a lot of this conversations about AI and the impact, it a lot of the times boils down on B2C. And it is important, right? Because B2C is the Facebooks and the Twitters, and the implications of that is on a political level, right? Like you see countries being affected by this sort of areas. But at the same time, the B2B space, the infrastructure that you trust on your day-to-day basis, the lifts, the trains, the I don't know, your doctor, your GP, everything that you use on a day-to-day basis that you don't even question, that infrastructure is also being replaced. And it is important to make sure that the trust is built beyond just the user itself, because there's many stakeholders, many of these clients which are B2B to C, right? So the trust needs to be established with the user, with the procurement manager, with the C-level executives, and the actual approaches towards the data that you store should be very important. A very, very interesting example is basically the way that Uber approaches privacy. Uber, from all the companies, approaches privacy. They actually have a very interesting approach with this thing called differential privacy. Differential privacy basically makes, by adding noise into the data sets, into the results of the queries, it makes it almost impossible to be able to gain insight of the data, but it still keeps the insight for you to actually get some metrics. And they give access to their analysts to be able to use and query some of the results on a country level or on a city level, but still providing the privacy that users deserve, right? So, and if you're introducing this process internally, it is also important to communicate those to your users, because that is ultimately how you do build trust. Another example is GDPR. When you consent to something storing your data, for example, you say I'm okay with this company storing my videos, and other services to extract things like your emotions, like the emotions from the videos themselves, or things like your voice, and build synthetic voice generators or synthetic face generators. So things like that may be implicit on metadata that should still be explicitly stated when you're using those data sets. And then the last one is basically data risk awareness. As we all know, that is what hacking looks like. But ultimately, also being aware that a very, very large percentage of data breaches actually are caused because of Joe sending the email to the wrong person, right? A huge number of data breaches happen because of that, right? So introducing machine learning systems, or just new systems, it will require and will open opportunities for new social engineering potential risks. So making sure that there's the right training with this deployment of the systems, as well as there's other areas like adversarial attacks of tricking the machine learning models with specific inputs, maybe adding a salt to the models, or retraining them every once in a while to make sure that the same inputs are not going to cause the same issues. And the last one is security breaches, which is also something to take into consideration. Again, these 8 principles are not about saying, hey, I'm following this, so I'm 100% bulletproof to anything that happens, but like with any other standards for cybersecurity, is not that you are fully bulletproof, is that at least you have some solid processes that allow you to mitigate some of these risks. And yes, so if these principles resonate, do join the network, i.e. our newsletter, for now. And in terms of next steps, is how can you start thinking of applying this into your actual projects? So wrapping up, today we covered a practical framework for responsible machine learning. All of you are still awake, which is great. And we covered also an overview of the institute and some next steps. So with that said, you can get the principles on the first link, the awesome machine learning operations list on the second one, and any questions, I'm happy to take them here through email or at the pub. Thank you very much. Awesome. So any questions? Otherwise, we can wrap up early. Oh, awesome.
So, is there any way to protect your AI being racist or sexist?
That's a good question. That's a good question. So there's definitely ways to mitigate it, and ultimately that does boil down for you to first of all be aware of what data sets you're using to train the machine itself. To train the model itself. If the model itself shows that there is a high importance on the feature of, for example, ethnicity, and the training data is coming in as active learning, i.e. it's actually training and retraining the model the more data it has, or for example, the data that you're getting is skewed, you may be getting a lot of examples towards a specific class, but very little for others, right? That may actually start becoming, and start making the model itself become much more biased towards a specific side. Whether it's going to become racist, that is really specific to the use case, right? So if you first try to identify what are the potential skews that your model might see, then you can start putting stuff in place like ensuring that the training data you're receiving at least a reasonably similar number of training examples for each of the classes, making sure that in some of the features that may cause this like racist inference results, maybe removing them and seeing how the accuracy reflects. So there are these best practices that you can approach. Unfortunately, there is no one silver bullet, and you could still deploy this Twitter bot that is going to be continuously trained. But at the same time, I mean, you could have seen that coming, right? Like if you just make like a Reddit bot and you just train it on everything, I mean, you know what to expect. So having the right approach into the data that goes in, and having the right monitoring, not just leaving it all the time as soon as you put it in production. Actually, one of the points that I mentioned in the previous the machine learning operations talk is when you deploy a model, you need to have two types of monitoring. The first type of monitoring is making sure that there's no anomalies, that there are no results that are unexpected, and the longer term is like continuous, like slower checks. So I think those approaches would allow you to mitigate a racist AI.
What about like having multiple machine learning models for the same stuff, but like different models, right? And then they can kind of argue to each other, like, hey, I would say it's like this, and this says like, no, it's like this, and then you have like 10 of those or something, and then you could say like, ah, okay, I see a meme there, or I see like, I don't know, a vote, like a democracy, ML, right? And then you could say, okay, 5 to 2, so it's fine.
Yeah. So
is this a possibility? I don't know. Like
100%. So those are basically some type of ensemble methods that you can have with like committees that basically choose based on like multiple models. Some of them may be the actual same model but with different hyperparameters. So all of this is things that you can actually approach, and it's about making sure that you number one are conscious that this exists, and number two make sure that you try them where relevant. So that is definitely one of the approaches to take when wanting to have much more flexible results from a specific use case. So that's definitely a way to approach the development of your classifiers. Yeah. Awesome. So any more questions? Cool. Oh, one more over here.
Yeah, so coming back to the earlier question, I mean, when you have this explainability in your models and you have some, you are aware that there might be issues and you look at, for example, the weights you set it, when there's a high weight of ethnicity, you might investigate that. But what if it's like an implicit feature in it, data set? So you have a set of features that are chosen or at least imagined to be impartial, and then it turns out that those actually carry the prejudices of the modeler as well, and actually can be used to identify ethnicity with a very high probability or something like that. How do you deal with something like that?
Exactly. So very good question. So that is basically back to analysis of features and analysis of the data itself. I mean, that is basically trying to assess the correlation of the features themselves. And that is a very good point, because there's actually been case studies where, you know, they remove ethnicity, but it still can be inferred from some of the other features. I think in some of these cases, you know, it's more specific to the specific use case in which you're implementing this algorithm. Sometimes you may require some of these features to be used, but then at the same time, that is when you need to have this like industry boards or this set of project leads that are doing the operational transformation to deploy the model, that need to make a call on how to deal with this or how to address this. And I think that is why I think a lot of the things that I try to propose in this first phase is to make sure that the data scientists and the machine learning engineers, they focus on identifying and documenting the biases as well as the implications, so that the right discussions can happen on how they're going to be used, right? Because I think a lot of the times the main issue is when that conversation doesn't happen, right? Like there is this machine learning model that is developed, and you know there's no awareness on the bias, and then it gets deployed, and then it turns out to be terrible. As opposed to if the data scientist is able to like give a breakdown of the importance of the features, then the right conversations can start to arise. So I guess, yeah, that would be the perspective. Awesome, yeah, go ahead.
You mentioned that very briefly, that you're also working in the direction of informing regulators and people who actually have a control over what models get put into production. So how can you elaborate a little bit more on the part? Because in the past there have been models in several areas which also have this effect that you mentioned, that they reinforce the behavior they were still to prevent more of this. For example, like grading teachers on the quality of their work in the schools, or sentencing reports and things like that. And how would a government or any regulatory body go about this and say, okay, you have to have certain standards like transparency or regular re-evaluation or anything like that? How would you put that in practice?
Yeah, that's a very good question. So, in terms of the way that we're approaching it is because it's very hard, right? I mean, anything to do with like policy making is very challenging, because once it's established, it is enforced. What our focus is towards this is making sure that in the first phase, having engineers and having technologists following these principles, as well as in the next stage, which is introducing it as processes, and the latter introducing the standards, is by gathering case studies. So making sure that we can identify areas where doing this or not doing this had a specific result. Say, for example, not having a human in the loop review process implemented for specific areas, right? Like very, very critical things that have high impact on somebody's life. And I think, high impact being like considerations of it will impact somebody for something that will affect them for more than 5 years, right? It's not something that just will affect them for a day and they're going to be annoyed. So I think it's making sure that we can gather case studies that then will help policymakers in those discussions. And the way that we're approaching is through the main focus on these three phases initially. Mm-hmm. And let's have one last question. Yes.
How do you handle the difference between the threshold of accuracy that a system needs to get to beat its human competition, so a self-driving car is absolutely crazy, versus the level it needs to get to gain societal acceptance? Self-driving car, you can't have one accident.
Yeah. That's a good question. That's a good question. So, let's actually break that into two, because self-driving cars are really hard, right? Like I was at this showcase on Monday that of this company called 5AI, and they were showcasing their self-driving cars. They had several stands which were covering safety, policy, prediction, and I think it was one more. But those people are incredible. They're pushing the limits on everything that we know in those cases, right? So that is really hard, because you know, you're dealing with this system that is going to transport people, and you know, the data that you can gather, you know, the label data that you can gather, you don't really have people jumping in front of your car every 3 seconds, right? And that's the ones that you want to train the car for, right? Like the outliers. So that involves building simulators that are close to reality. It's really hard, right? So let's take a different one, like classification of specific texts, you know, or images, right? Like for medical purposes, right? So your question is, how do we know when, number one, the machine is better than a human, and number two, it's okay to deploy, like societally okay to deploy? So that is ultimately the question of the similar way of how you deploy, you know, other software, you know, by seeing what is the performance of the humans that are currently doing that job, versus, you know, the systems that you're putting there, making sure that the accuracy, and not just the accuracy, but also the precision, the recall, across a significantly representative set of data. You know, once you're able to prove that it's, you know, at least the same or more accurate, then that is when you would be able to start deploying it. If there are some potential areas where it won't, that is when it's utterly necessary to make sure that you still have a human-in-the-loop review process, right? And that's why human augmentation, as opposed to, you know, just artificial intelligence end-to-end, tends to work best, because you have a human and a machine learning model, you know, working together. You need less resources, but still, you know, you have much higher accuracy than just the model. Right, so I think it's on the combination of all of this. Right now, they aren't like best practices set and standard, but you know, that is why it's important defining your accuracy, making sure that it's explainable, making sure that, you know, you understand your bias of representative, how representative your data sets are, and then the assessment of, you know, what accuracy is okay with or without human in the loop. Awesome. So, any more questions? Super keen to dive more into this. I'll be at the party or event or pub or whatever is this evening, so happy to, you know, just discuss more there. Awesome.